Hello everyone and welcome back to Manic Analytics. I'm very pleased to have you back once again. In today's video, we are going to be conducting an exploratory data analysis, and the data or the subject for the today, as I said, is an exploratory data analysis, and the data that we are going to be analyzing will be an HR employee data. So we are going to be using that in this analysis. So before we get started, as usual, please, I'm welcoming you to this wonderful community. So please consider subscribing to this channel. You can also hit the notification bell so that you never miss any of our video updates. So with that said, let's get started with the analysis for today. So as usual, we're going to start by importing the necessary libraries. So I'm going to import the libraries. So for the libraries, for this case, I will be using the pandas, NumPy, Matplotlib, Seaborn, Plotly, and these ones maybe if we encounter some warnings which maybe sometimes are irrelevant, so we'll just be ignoring those. So after we import the libraries, we can then move on to import the dataset that we are going to be using this analysis. So with the datasets, I'm using the read CSV function, and this is the file path, and this is the file name. Okay, and I'm just using the head method to print the first 5 rows of the data frame. So this is the dataset that we are going to be using. So if you use the head method and get an output, that means you have imported the dataset. Then after this, we can do a summary. We can get a summary about our data. So this I'm going to use the info method, df.info. When you execute this, you can see that in our data frame, we have a total of 17 entries. So those are the number of rows in our data frame. And you can see we have a total of 13 columns. You can also get this. You can also see the different data types for the values in the respective columns. And also, when you look at the null count, you can see that we are missing some values in some of these columns. You can see like the column education, we have a less count. So definitely we are missing some values in those columns. So in this case, I won't be delving deeper into the different ways you can use to solve issues about missing values. So for this case, I will just be dropping those missing values. Or if you can provide a rationale for as to why we are dropping these missing values, you can see we have a missing value in the column or attribute education, and we are also having missing values in the column previous year rating. So when you look at these columns, I can see can you find a correlation? Okay, let's not go into deeper about that. So let's not focus on that for today. Let's just move forward and drop those. We'll just drop those missing values, but let's determine maybe the count of the missing values. So df dot. So here I'll be using the isNull function. Null dot so isNull Then we sum. When we execute this, so for the column education, you can see we are missing a total of 771 values, and in the column previous year rating, you can see we are also missing about 1,363 values. So when handling these missing values, as I said, we're just going to drop those missing values. So when we are handling the missing values, here we will just be we just drop those missing values. So df dot we'll use the drop then in place use true. Then after this, we can just repeat this code here. Then to see definitely we are going to be getting 0. So that means we dropped those missing values from our data set. Okay. Then if we again run the info method, here from the output you can see we have a total of after dropping those the missing rows in our data frame, you can see we reduced that to about 15,424, let's say, rows in our data frame. Don't have missing values. So as we did, this is one of the ways that you can use to deal with the missing values. Other ways, let's say you can use the simple imputer and then specify specify the strategy. Let's say if you want to use the median, if you want to use the mean. So for example, if I'm going to use, let's say, the median I think is the mod I think is the most common. If you can just search for mod is the, let's say, in statistics. For mod, I think it's the value that appears most frequently. So for example, you can use the simple imputer to deal with the missing values. So for example, if you're going to use the mod, and as you can see, the mod is the value that appears the most in a given data set. So what essentially you will be doing is that you'll be looking for the most common value in both columns, the education column as well as the previous year rating column. And after finding that the most occurring value, then you'll just be using that value to fill the missing values. But for this case, I just resolved to just drop those missing values. So after dealing with that, we can then move on to, let's say, another technique for cleaning your data, or for data cleaning step. So I'll be checking for duplicates. For the duplicates, then I'll use the duplicated method. So df duplicated, then false. And from here we can then I'll just sum. This should be outside. So dot sum. So when we execute this, you can see we have a total of 3 duplicated values in our data frame. So we can then move on to drop this duplicate. So when I use the keep equals false, that means it's going to count every duplicated row and provide a summation of the duplicated rows in the data frame. So it's not going to, let's say, skip the first row among the duplicates. So it's just going to count every duplicated row in our data frame and give us the summation of that. So after this, then we can then use the drop duplicates method drop. So for example, if you're getting 3, that means since it's counting every row that is duplicated, so 3 means that it's counting all. So when we are going to drop the duplicates, we are going to drop 2 columns and remain with 1. So df.drop duplicates, then I'll use the in place true. Then when we drop these duplicates, and then let's again run the df.info. When we execute this again, earlier on you can see we had 15,424, but here we have 15,422. That means, as I said, we did not drop all 3 columns. We dropped the 2 columns, the 2 successive columns that were duplicates. So after dropping that, you can see we are remaining with 15,422 rows in our data frame. Okay. So another thing that we can do that I want to maybe rename these columns and provide names that are a little bit descriptive. So I'm going to rename the columns in the data frame. So I'm going to rename the columns. So for the columns, so I'll use the rename function. So df.rename function, then specify the columns. So for the columns, if you want to get the columns, you can just print df.columns. So with this one, with this, you're going to get an output that displays the columns in your data frame. So after this, we can just copy this and paste, then provide the new column names. Okay, so I'm just going to do that. So for the columns, so you can see for department, for the column department, so I'm just instead of lowercase d, I've just used an uppercase letter D. For the region, the same, education, and then say, for example, the column KPIs met more than 80. So I've just used KPIs more than 80 using the this sign. For example, okay, then for example, length of service, we can just substitute that to tenure. So tenure maybe shows the length of service for each employee. Previous year rating, can just shorten that to previous year. Okay, so as you can see, I'm just trying to rename those columns to be a little bit descriptive, so that we are able to see what we are doing. When doing this renaming, I'll also want to maybe drop employee ID because I don't see its importance. So when dropping this, so here we are just going to be renaming these columns. As you can see, we are using a dictionary and we are supplying the key and the value pair. So you can see that. Then from there, we can use the drop method now to drop the employee ID column from our data frame. So again, you can just use, I'll just say df.drop. So we're going to, again, as you can see, this is just we're going to drop the employee. This one is the employee underscore ID column. Then I will just use in place to just use that. Then after we are done with this, I can then use the df.head method just to see what we are getting from this. So we are getting an error. Column also is supposed to be columns. After we execute that, you can see at least now we have these are the columns that we are remaining with. You can see at least we have tried to rename those columns. At least they look presentable as of now. Okay. So the next thing, I think, under data cleaning on our data, so some of the steps that we performed for data cleaning include the dropping of the missing values. So that's a step under data cleaning. So maybe here we can just say data cleaning. So this step is very important in data analysis because you need to present accurate results. So, and your results want to be as accurate as possible when you are, let's say, missing some values, or your data is abnormally structured. Okay. So under data cleaning, you can see we dropped some missing values. We also checked for duplicates and dropped the duplicates. So we didn't want to deal with duplicated rows in our data frame. And after that, maybe we can say we renamed the columns so that we provide descriptive names for these columns, these attributes. Okay. So then after that, we can then move on to the main goal, to the main agenda of today, which is about the exploratory data analysis. Exploratory data analysis. In other words, you can just call this as EDA. So with the EDA, so with the exploratory data analysis, the main thing with this is all about you're trying to tell a story using your data. So, for example, you're given this raw data and you are being told, please tell us what does this data tell us? What can you infer from this data? So with the exploratory data analysis, we are trying to answer some few questions, some questions here and there, or majorly we can say we are trying to use our data to tell a story. Okay, so that's what we are going to be doing under this section. Under this exploratory data analysis, there's one important thing that we will be tackling, and that will be about something known as feature engineering. So did want to place that under data cleaning because I think feature engineering is a further step. Is another further step above data cleaning. Data cleaning, we're just trying to correct the inconsistencies in our data. But feature engineering, we are trying to fine-tune or shape our data in such a way that the story that we are going to tell with the data will be more conclusive. Okay, so I'll start with the feature engineering part, so that then we can move ahead now to telling a story using our data. So as you can see in our data, we are having, let's say, columns, let's say the department, region, education, recruitment channel. You can see those columns are containing categorical values. I'll be doing some bits here and there, so that under feature engineering, so that maybe you can get a clue as to what I'm trying to do. So, for example, let's start with the column. Let's start with the column region. Okay, let's see what values are under the column or under the attribute region. Okay, so with the column region, let's see. So df, and then we can say region. So, so for region, we can use the unique function, and the unique function is going to print df. So when we use the unique function, it's going to print out the unique values under our attribute region. As you can see, these are the unique values under the column region. So from the look of things, we are dealing with say a region between region 1 to region, the highest is 30, I think 30, 32, if I'm not wrong. Okay, let's say 32. So we are dealing from region 1 to region 32. So under feature engineering, so what we can do, we can use a general term to maybe we'll start by grouping these regions. So let's say, for example, let's say region 1 and region to region 10, we can assume that those regions are maybe located in the same province, something like that, or in the same geographical region. Okay, so we can say those are small districts under a bigger region. So we can just group, let's say from region 1 to region 10, we can generally group that and say that this is region 1, or we can say this is province 1, okay? This is county number 1, okay? Then between region 11 to region 20, you can group that and say this is province 2. Then we go again region 21 to region 30, we can then say this is province number 3. Okay, so I think you get what I'm trying to show here. So to group the different regions and just use a general term for the regions that are close to each other, I'm going to use I'm going to create a function, and in this function I'm going to specify those specific requisites. Then we, after specifying those, we can just execute this function, and it will group these different regions into the general clusters. Okay. So I'm going to, for this case, I'm going to use a function, as I've said. So def, this is a function. So I'm going to specify or name my function. You can say map region to say less labels. So we can just say map region. And we can provide our argument. So this is a region. Then in this function, we are going to specify what this function is going to be doing. So you can say if region in so I'm going to say if region is in between region 1 and region number 10. So we can say, so if region in either region 1 to up to 10, then we are going to region 1 to region 10. Then we are going to return. Then you can say, let's say province 1. Okay. Then after this, as you know, else if elif, so elif region, you can say region in, so here we reached region 10, so we can say from region 11 to region 20. Okay, so if this one is in, so region, so between region 11 to region 20, then we can just, let's say we can return, say province 2. Okay, so we are going to repeat the same. So again for province 2, then again if elif again for between region 21 to region 30. So this one you can just repeat the same. So return this one you can say province 3. Okay, and between okay. So getting an issue. It's supposed to be on this. Okay, that's correct. So between 31 and 40, here we can return. Then we say return. Let's say province 3, province 4, and anything that is above, let's say 40 and above. So here we can just use now the else. We can say return, say province 6. Province 6. Okay. So after we are done with this, we can then in our data frame we can then create a new column. Okay, so return, not return. So we can say, let's say you can use just province, and then so this will be the in our data frame. We are going to create a new column province. So our results will be saving in the new column province. So for the function, it will be dealing with the results under the column region. So region, then we are going to apply our function map region. Okay, just copy this, then paste it here. After this, when we run, use the df.head method, supposed to be apply. That we're getting some, supposed to be okay. So this one is the former column region, and as you can see, we included the column province. So the column province contains data that we manipulated from our original column region. Okay, so we can then move on. So now this column, this attribute region now becomes irrelevant now in our data frame, because we use the data in that we manipulated the data here and there to come up with a new column province. So this column is now irrelevant. So we are, basically what we are going to do is to drop this column, because now it's not relevant in our analysis. If we want to check the new values under the column, the new column that we created, so we can just, let's say, copy this and change this column to province. When we do this and use the unique function, you can see that we have the province 1, province 2, province 3, and province 4. And when you go back, you can see how we try to group these regions into the different provinces. Okay, so that's a step under feature engineering. Okay, so we tackled the attribute region. So we can also do the same, let's say, for the department. Okay, so again, let's see the column department. Let's see how many unique values do we have in the column department. So again, department, then you use the unique function. The unique function, it will too fast. I'm doing a lot of spelling mistakes. So for the unique, for the column, for the attribute department, you can see we have the HR, sales and marketing, procurement, finance, analytics, technology, operations, legal, and research and development. We can also combine some departments. So for example, for the column procurement, you can combine procurement to be, we can combine the column procurement and finance, so that they just, we call them procurement and finance. Okay, and for the analytics, we can combine analytics and technology to be analytics and technology department. Okay, You can also combine operations and legal to be operations and legal department. So we just combine those departments. So we are trying to see which functionality of a department are congruent, or this department works closely with this department. So instead of having splitting those departments into sub departments, you can just combine those departments so that they're just one department. So we're dealing with this, as you can see. We are trying to easen when we will be dealing with the analysis part. We have few attributes. You have few values under the specific column, and then it will be easier for you to analyze and trying to tell a story with those values. Okay. So with this, I won't be using a function. Here will just be mapping, creating a dictionary, and then just mapping those values to each other. So okay. So again, here departments. So for the departments, so I'll just create a variable. So mapping. Here, as I said, we're just going to create a dictionary. So for the procurement, here, we're just going to, let's say, procurement and finance. So you can just combine this. So you can map this. So for any value that is procurement, we're going to change that to procurement and finance. Procurement and finance. Okay. Procurement and finance. So we need to remove this. Okay. So that is for procurement, and also for any value finance. Again, we need to change that to the same. So for finance, again, we're going to be replacing that with the finance and procurement. For the rest, let's say analytics. As we said, we are combining analytics and technology. So this is the analytics and technology. We're just going to change that to analytics and technology department. Operations and legal, we are combining that to operations and legal. Okay. So after this, we can then earlier on here we said department. So we can, let's say, use a plural, departments. So we can just say department. So with an S. Okay. And so we say df. And here this one was for this one, the department. Department. Okay. So here we're just going to use the replace function and provide in the name of our variable. Then after we are done with this, we can then drop the department column in our data frame and use the head method to see. So again, you can see we have the departments column, this column that we created here. Okay. So I think that's it. So I want for education. Let's see, education. For education, let's see about education. For education, bachelor's, master's, and above, below secondary. We only have 3 categorical values or unique values under the column. So 3 is quite a small number, so I won't be doing some merging here and there. Okay, I think that's it. So for the province, we did some feature engineering. For the departments, again, you see we did some feature engineering, trying to merge departments that are closely resembling each other. Okay, so I think that will be it under feature engineering. So you can see how we did that. So after that, maybe then we can then move on to now the exploratory data analysis itself. So we are trying to now start telling a story now using our data. Okay, so I'll start. Let's start with the, let's say, employee education and try to see under employee education, we're trying to, the employee education, let's see the count of employee, let's say how many employees are bachelor's holders, how many employees are having masters and above, or how many employees have an education level below secondary. Okay, so here again, just create a variable education, then the column in question here is the column education. Then here we can just value counts. Then we can reset. So here we'll be generating a new series. So we can reset our index so such that our new series has a new index, and rename the column. Okay, so here, so education, then you can say education. Getting an error, so it's supposed to be period. So with the education, you can see education and the column count. So this just counts how many employees do we have with bachelor's, master's and above, and secondary. So from the from this result, you can see that most of the employees are having a bachelor's education, and it's about 10,000, over 10,000, and about 4,700 employees are having masters and above. And when it comes to employees with below secondary education, we are only having 168. So basically here you need to provide some insights about your data, and for the insights we can say, just use this as markdown. So for the insights about employee education, you can see that most employees are undergraduates with bachelor's degrees, 10,464, followed by those with masters and above, 4,790. Okay, and 168 employees have below secondary level education. Okay, you can also check for department with most employees. So which employee no, it's supposed to be like this. So which department is having majority of the employees? Okay? So here we can again say, you can just copy this. So basically we're just repeating the same thing. So here we can, instead of education, we can use department. Just copy this and just do this, paste. Department, so departments, supposed to be departments. So instead of education, you can just change this to departments and execute this one. So when we look at the departments, you can see we have a total of 6 departments. And when we look, you can see that the sales and marketing department is the department with majority of the employees, 1,601. then followed by operations and legal with about 3571 employees, followed by analytics and technology department with 3420 employees. The least department, or the department with the least employees, is the research and development. I think so. It's about with 299 employees. Okay. Employee distribution by different province. So we can also tackle that. So employee distribution by province. So again, let's use this as our markdown. So when we look at the employee distribution by province, so we can just change this to province. Province is the column, I think so. Province, yeah. Province value counts. And I think with that. So we have a total, as you can see, we have a total of 4 provinces, province 1, 2, 3, and 4. So most of the employees are coming from province 1, 6,447 employees, followed by province number 2, province 3 with 4,450 employees, then province 2 with 3,513 employees. Okay. So then, so we can with this you can see the different how now we can see we are trying to tell a story now using our data. So we started by employee and education. We saw how the company, the education level of the employees in the company. We also moved to the department with the most employees. So we saw that sales and marketing department is the department that has the most employees. Then in terms of employee distribution by province, like where are most of our employees, in what region or in what province do most of our employees come from? Okay, you can see that province 1 is the province with the most employees, with a total of 6,447 employees. Okay, so you can see now we are trying to tell a story with our data. Okay, so we can then move on to another metric that we can use. So we can, let's say performance. We had the column average training. We can let's say we can do another analysis. For this case, you can say performance by gender. So we are going to select different metrics and see how the different employees according to gender are performing based on those metrics that we have selected. Okay, so gender, then so we can say df dot. So here I'm going to use, so because we are dealing with different metrics, more than one, so I'll be using the group by method. So group by. So df dot group, if that's correct. So group by. So gender. Then I'm going to use the aggregate function, and in the aggregate function, this is where I'm going to now specify the different metrics that I'm going to be considering. So I'm going to consider this according to, let's say, start by the total trainings. So total trainings. So let's see, according to gender, it's the female or the male that have attended most of the trainings. Okay, So here we're just going to sum. In terms of average training score, so let's determine between the female and the male. Let's compare them according to the average training score. So here I will just use the mean instead of the sum, because we are dealing with the average. Then let's say in terms of age, so the mean age. So here we can just check about the mean age between the female employees and the male employees. So in terms of, again, tenure, so we are trying to see here again. I'll just use the mean. So with the tenure, we just to see earlier on we saw that tenure is the length that an employee has stayed within the company. So with tenure, when you're comparing within the genders, so we are trying to see if either male employees or the female employees have a tendency to stay long as workers or employees in the company. So again, for the KPIs, so we are trying to see which gender has more than 80 KPIs. So KPIs, I think those are just key performance indicators. Then you can also compare in terms of total awards. So which again, here you can just use the sum. Okay. So again, we are going to reset index. So that's that. Then after this, we can maybe rename these columns. Should we rename those columns? Yeah, you can just rename the columns. So gender.columns. Gender.columns. So gender, either male or female. So total trainings, I think this will remain the same. So here I'm supposed to use supposed to provide this as a list. So total trainings, I think it will remain the same. So average training score, so here and maybe shorten this, say AVG, average training score. Then for age, you can say average age. Okay. Tenure, we can also say we are dealing with mean. So this one can be average tenure for male employees and female employees. For KPIs, we can say let's start with, let's say total KPIs above or greater than 80 between the 80. We can say maybe add achieved. Then we can say total awards. This will just remain the same as total awards. Total awards. So just copy this, paste it here. Then after you're done with this, you can just say gender. So when you execute this, getting an error, columns KPIs greater does not exist. So it should be KPIs. Okay, so now we are getting an output. So when we are comparing performance based on gender, based on the different metrics that we selected, So in terms of total trainings, we can see that the male employees attended most of the trainings, about 13,000. So when we sum up the total trainings attended by the male employees, you can see that they attended 13,834 trainings, and the average training score based on this, you can see that the female employees it's about 63.7. So despite them attending less trainings, you can see that in terms of the average training score between the both genders is almost the same, 63.7, 63.2. In terms of average age, again, you can see 35.6, 35.6. So in terms of average age for female employees and male employees is almost the same. In terms of average tenure, it's supposed to be tenure. We can see 6.25 years for female employees and 6.26 for male employees. Again, it is quite close. In terms of the total KPIs above 80 achieved, it's almost 3786 for male employees and 1790 for female employees, almost half. In terms of total awards, we can see that again the male employees have total awards that is almost 2x. I think it's 2x those of the female employees. So this information, we can plot a bar graph to represent this information. So we are going to plot a group bar graph so that we are able to group this information into a bar graph, so that when you're going to present this information, I think using a bar graph to represent this information, it will be quite useful. So for plotting, I'm going to be using Plotly. I think Plotly is, as in my previous analysis, you can see that Plotly is quite good in terms of this analysis, because it gives you that space to maneuver. So you can bend and twist your charts so that they can suit your preferences. Okay, so I'm going to use Plotly to plot grouped bar graph. So fig, say px.bar. So we're plotting a bar graph, and we are using data from the gender. So gender. So our axis will be gender. Okay. Then for our y, it will be from total training up to total awards. So that will be our columns. And just paste it here. Then in terms of, so I'll provide supposed to have a comma here. So here again, just provide a title for the chart. So here we can say performance. So performance comparison with gender. Then remember, this is a bar graph, so we are going to be grouping those bar graphs. So bar mode, we can just say a group. Okay. So after this, maybe you can for our chart, let's say let's layout. The graph. So fig dot it's out. So here you can say the width and say 1100. Then for the height you can say 600, and the bar gap for the bar separation. So here we can say let's say 0.2. Then after this, we can then display our charts. So we're getting some error, so comma here. Bar graph getting an error. Spelling mistake. Supposed to be that correct? HEIGHT. Right. Okay, now we are getting our chart. So performance comparison with gender. So we have the variables here. So we have a key or a list of the different variables. So with the chart, for example, if you just want to compare about in terms of the total training, so you can just click here, and these other variables will be redacted from the chart, and you can see we're only remaining with the total training bars on our charts. So you can see that in terms of the female, you now see 5405 total trainings, while for the male employees 13,000. Okay, so if you want to compare in terms of the average training score, again do the same. As you can see, in terms of total KPIs achieved, you can just click the total KPIs above 80, and you can do the comparison. Okay, so that's why I like Exploratory, because it gives you that room or space to wiggle around with your charts. Okay, again here we can provide some inferences that we have learned. We can see that male employees underwent more trainings. So in terms of the total trainings, we can see that they underwent more trainings. Then both gender have almost similar training scores. So you can see 63, 60, 63. Average age is about 35. Then average tenure is about 6.2 years. Male employees achieved more KPIs than their female counterparts. Again, male employees got more awards than the female colleagues. Okay, so we can also do a department-wise analysis. So a department-wise analysis, similar as what we did earlier. We're just going to repeat the same thing, but for our department now. So the department-wise analysis, so we are going to create a variable departments, then use the function df.groupby, then specify the column that we're targeting, that's the departments column. Then we use the aggregate function, and instead of aggregate function, we are using a dictionary. So with the dictionary, we are going to specify the key and the value pair together. So and this will be the different metrics that we are going to be using to analyze under the department-wise analysis. So for the department-wise, again, average training score, we are going to find the mean. So under the different departments, so you're trying to see the average training score for employees in the different departments. See how they are performing. Again, age for the different departments, tenure, the mean duration or the length of employees in the departments, the different departments, the KPI above 80, and the total awards in each department. So we're doing this irrespective of the population of employees in the different departments. Of course, the 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 number of employees in a given department, since they are not the same, it will have an impact for, in our case, in our analysis. But if you are dealing with a case where the employees in the different departments, or the different departments have close to the same number of employees, then this analysis is quite it will work well for that. But here we're just doing irrespective of the population of the different employees in the different departments. Okay. Again, when you execute this, so these are the departments: analytics, technology, finance, HR, all the way to sales and marketing. So when we are comparing the average training score for the different employees in the different department, so you can see that research and R&D department. So earlier on we saw that R&D department is the department with the least number of employees. So if you have the least number of employees, then such metrics like the average training score, because of the small population, then you are going to get higher scores. Okay, so you can see that is the same. It's happening here. So 84.4% is the average training score for the employees in the research and development department. Sales department is the least. Again, you can see that sales and marketing is the department with the highest number of employees. So when you are calculating the average, and remember you'll be dividing with the total sum of the population. When you have a higher value in the denominator, then you are going to get a less value in terms of the quotient. Okay. In terms of average department H, these are the values for that. You can see that analytics and technology, you can see that finance and procurement has the least age for the employees. In terms of average department tenure, you can see that of all departments, research and development department, you can see that workers under this department have the least working period. Okay, but for the sales and marketing, we can see that most of the workers, it's about 6.3 years. So most of the workers tend to spend to. So in this company, you can see that the sales and marketing department, we have the most loyal employees, because they take maybe they work for long. No, I think it's the operation and legal. Sorry, the operation and legal department is the department where you have the most loyal employees. In terms of the total KPI achieved for each department, we can see that sales and marketing, the again operation and legal is the department that got more of the total KPIs. In terms of department awards, sales and marketing, the one is leading about with 100 awards. Okay? Again, with this information, it's quite easy to plot a bar graph. So with the bar graph, this is the bar graph for that department comparison. You can see these are the different departments on our x-axis, and the values or in the x-axis, in the y-axis, sorry, and x-axis is the department. So here you can now do that comparison again, now visually. So again, you can just you can visually see this information. Okay. We can also do another. Let's add one. Let's say employee comparison with education. Okay, employee comparison with education. Just so earlier on we can let's provide our insights here. So these are some of the insights that you can obtain from this analysis. Okay. You can also do employee comparison with education and see how what we can obtain from that. So when we compare, oops. So employee comparison with education. With this analysis, you're trying to see, we're trying to compare the employees and education and see how they are faring on. So as similar as what we did earlier, so group by education, then you can see we're going to compare basing on these metrics. This is the output from that. So let me just use the grouped bar graph so that we can able to compare this. So in terms of total trainings, basing this on the education levels of the different employees, you can see that below secondary, this is the if an employee has a below secondary as a highest form of education, you can see that they tend to attend more trainings, okay, followed by bachelor's and then master's and above. So again, this is what is expected, because I think when you have a master's, you are almost in the highest form of education, so you will require least training. But if you have below secondary education, maybe you will tend to require more training so that you are able to fit that job description. Okay. In terms of training score, you can see that below secondary education, we saw that they attend more training. So again, in terms of the average training score, you can see that below secondary we had least number of workers. So we expect that the training score will be higher than the rest. Does not mean it will be higher than the rest. Okay. So here this metric won't be inclusive because of the difference in population of the workers, because we are dealing with the mean score value. Okay? Average tenure, you can see that if you have a master's degree and above, the chances of you working longer is higher than having a below secondary education. Okay? In terms of KPIs, we can this one is for KPIs. So in terms of KPIs, you can see that those with bachelor's education, they achieved more KPIs, followed by masters, and then below secondary. Then in terms of total awards, okay, so I think this one is straightforward because they achieved more, or if they beat the key performance indicators, so the bachelors had more. So in terms of awards, expect them to have more awards than the employees with below secondary education and the masters and above education. Okay. So we can also provide insight for this, so that when you are giving a presentation, it will be easier. So when someone is going through your work, they're able to see these key insights. So they are important because they just tell them what you are basically doing. Okay. We can also use the region. In terms of region, we can also add that. So in terms of region, basically we can just repeat the same thing. So this thing they're just repeating the same things. So you're comparing employee and region. So this one is supposed to be province. So province 1, 2, 3, and 4. So for province 1, in terms of average total trainings, so workers from 1.26, 1.27. So workers or employees from province 3 required most of the trainings. In terms of total KPIs achieved by workers from the different employees from the different regions, you can see that province 1, they achieved most of the KPIs. In terms of average training score, they are almost evening out, except for province 2, where the training score is a little bit less than the other regions. We can also plot a bar graph for this. It's supposed to be province. Just change this to province. I think the rest will remain the same. According to region, we need to by province do this. So again, you can do that comparison. So with the different variables, so you can see how they are competing or matching up. I'll just provide the insights for this. So with the insights, so maybe if you are going through, you can add other insights from this. Okay. Another thing, I think this one will be the last thing. So I will be comparing the previous rating and the average training score. So maybe here I'm going to be doing it a little bit different. I'm going to use, let's use box plots. Let's use box plots to plot this and see what we will. So we are comparing between the previous rating and the average training score. So basically, we're going to be using a box plot to tell us if the previous rating has an influence on the average training score. Assuming that the average training score is a value that, for example, if you're going to be conducting training this year, so we assuming that last year you conducted another training or not. So we are going to be it's something like that is cumulative. Okay. So here we're going to use a box plot so that we are able to see if the previous rating and the average training have some sort of correlation. So with the box plot, so I'm going to set the plot. So this is the figure size. So plt dot figure. Then we can say fig size. So for the fig size, we can just say 10,6. Then after this, we create a box plot to compare the distribution of average score with the previous rating. Okay, so here I'll use the Seaborn library, so box plot. So our X will be the previous rating. Then our Y will be the average. As the average training score. Then our data is ADF. Then from here, we can then provide the title. So the title for this will be say relationship between previous rating and average training score. Just say this. And average training score. That's it. Then plt.xlabel and say previous rating. And then our y label one will be the average training score. To close parentheses. So this is the box plot, and from the box plot we have the average training score on our y-axis and the previous rating on our x-axis. So when an employee had a previous rating of 1, you can see that 40 is 50, 60, about 50. They had an average rating of about 50, let's say 55. But if the previous rating was increased to about 2, you can see that the performance, the training score increased to about 60. And if the previous rating was about 3, you can see that the average training score also increased, let's say to about 60, 61, 60, 61, about 61. And between 4 and 5, you can see that there is some consolidation in terms of the average training score. So what can we deduce from this box plot? We can see that as the previous rating increases, if one has a higher previous rating, the chances of them scoring or the chances of them having a better score also increases. So having a lower previous rating, the chances of you performing better is quite low. So we basically can say that you had so the previous rating, if you have a high previous rating, that means you performed better in your previous let's say previous assessment. Okay, and if you performed better, that means you also had a better training score in your previous assessment. So someone with a better previous assessment, the chances of them performing better in the upcoming assessment also increases. So that's what you can see with the box plot. So for the box plot, I've been using this line that cuts this this line that is across this box. So this line is the median. I think it's the median value. So it tells you where the median value for each box plot. So as you can see, the median value kept on increasing as we increase the previous rate. Okay. So again, this could be my insights from this box plot. Okay. So I think that's it for this analysis. So you can see we have performed different exploratory analysis. We have made some comparisons between the different attributes in our data frame. So you can see how we can perform these comparisons. So with the exploratory data analysis, we have now seen how we can use our data that we are given to manipulate our data with the feature, like using the feature engineering, so that we are able to position our data in such a way that when we start doing the different analysis, we are able to get some more information about our data. Okay, so that's what we have been doing, and you have seen how we can manipulate our data so that we're able to get some insights from the data. So I think that's it for today. So that's it for today. Once again, thank you for your time. And before we end this session, please consider subscribing to the channel. Hit that notification bell so that you never miss any of our video updates. Once again, thank you for your time. And until next time, see you. Bye-bye.